Hmm. Good morning. Hannah asks, did I get a haircut? I did. I actually do it myself. Yeah, so this morning I guess a little fun fact for you guys. I have been a student here since 2014. I got my undergraduate degree here, and I was a swimmer here. So I've always, not my whole life, but I've always kind of gone with the shaved head. I prefer it. And given our stay at home activities for the past year or so, it's pretty easy for me to just do it myself. So yeah, I did get a haircut. Thanks for noticing. Good morning, Pig, Yang, Chef, Sake, Uchu, Male. All right. Let's see. So today is, I don't know, day 2, I guess. Good morning, Cade. I'll call you Cade. YCS, Waffle, Synthos. Good morning. Welcome. So I just would like to start by saying I'm going to start keeping track of my participation. So I'll actually go back after the stream and kind of review it since I have the chat available to me. But if you haven't let me know what your Twitch ID or Discord name is, please email it to me or go to the Google Drive document and put it in when you get the chance, just so I can keep track of who you are. All right? So we'll get that out of the way. I guess I'll open up this next. All right. So I know some of you have gotten started on homework. I just kind of want to say a few things about that. Got your jug of coffee. I'm happy to hear that. I got my jug of water. So with the assignment, this is my personal preference. It's probably different for other sections, but there's some suggestions for functions that you should have. Personally, I don't care how you make this program work. So if you actually don't, if you kind of spaghetti code it all in main, I'll be okay with it for this assignment. For the future assignments, you're likely going to get skeleton codes. If you don't know what that is, it's kind of a coding file that's kind of filled out already, and there's some components that you'll need to fill in. But for this one, there is no skeleton code. So if you do follow that PDF and you kind of use all the functions that are recommended, that's totally great. But if you say, you know what, screw it, I don't like this function, you can do it however you'd like. Synthos, I'd say yes. Today in my review, I'm going to go over 3 functions that you can use for that. IsPunct is not one of them that we use, so I will kind of review those today. The 3 functions that we are looking at are, let's see here. The 3 functions that should do you enough work are these ones here. So this is alphanumeric, meaning is it alphabetical or is it a number? And this one is alphabetical. Is this a letter, basically? So anything that's not a letter or a number could be considered punctuation, maybe. But what if there's something that's not considered punctuation, like maybe a pound sign or hashtag, however you kids call it? So, yeah, you're welcome to if you'd like, though. So here's how today's going to go. I would like to give you as much of a review and as much of an example to try to get you guys started on this assignment. I know some of you have even reached out to me to tell me that you took kind of a beginner, a CS 135 type class somewhere else. And so you might know Java or something. So today we're going to write a program in C++ to help you get started, and it's going to be kind of based off of this assignment. It'll be actually very similar, but I can't do it exactly because that'd be no fun for you guys. So our goal for today is we are going to read in this text file that I've created. Now, the only thing in this text file, are numbers. But as you can see, some of them are in digit form. And the rest of them are in, they're spelled out. Some of them have punctuations on them. And so basically we're going to read in all of these words. We're going to strip them of these punctuations. We're going to convert them to lowercase. And we're going to kind of count them all. Okay, we're going to convert them also into digits. So this is very similar to your assignment, just a little bit different. So there's a few things that we'll talk about today. Of course, if you have any questions, you can stop me at any time. You can ask me to slow down and all that stuff. So to begin, of course, when you're writing your first C++ code, we should include some libraries. Of course, IOStream will almost always be included with every single program you write. And that's likely because you use cout, cin. So usually we include this all the time. Now we're going to do some file operations. Does anyone remember what the library for file operations are? And then we're also going to be using some functions called like toLower and stuff. Yeah. Fstream would be our. Fstream stands for file stream. So that's what that F is there for. So we're going to use Fstream for the files. Now, we do have access to strings, right? That's a data type that's included in C++, but we don't always have access to these nice functions. And some of those functions include stoi, which we'll use today, toString, perhaps toLower, though I'm not quite sure if that's in this library. So what's the final library you think we should include? Now, TopWolf is talking about string streams here. I will not spend any time on string streams this semester. You are always welcome to use them if you'd like, but that's not the library I'm talking about. So this is for our files. And then the last one, close. I just want to include string. All right, this is for these functions here. So once we have all of our libraries, which gives us, you know, some functionality here in our program, the next thing we're going to do is always type this. Later this semester, we'll talk about what a namespace is. But within this namespace, std contains things like cout. It contains things like cin. And when we're inside of our program and we want to print something, I kind of want to leave this thing off. I don't want to have to type std every time. So when we say using namespace std, it allows us to reference things like cout and cin without actually having to use this thing here. And we'll talk about what this is later in the semester. So those are the first two things that we need to do always. And then finally, we need to have an int main. Now I'm old school. You do not have to have this return statement down here, but I always will. All right, because main is an integer function, and I wouldn't be able to sleep at night if I didn't return an integer at the end. So you may have, like I said, been taught that this is not required. All right, and this is where our program starts. So that's your basic C++ template. All right, so for those of you who are not super familiar with C++, this program will compile as is. So in C++, whenever you run a program, it depends on where you run it, but programs, when they close, they return with some value. And so they call them exit codes. And so if I return 0 from this program, that means exit code 0. And that's universally, means that it was a successful run. Uchu, to answer your question, I will be uploading this file. So you can just watch if you want, if that's good for you. But if you feel like you should be typing along, if that'll help you, you might want to do that too. But of course, if you're watching on a little laptop, it might be hard. I have two screens here myself, so it might be easier for me to do that. But yes, I will upload this file. So back to answer this question. Exit code 0 means a successful run. Yeah, and if I return 1, the operating system will interpret that this program did not exit successfully. And so there's a bunch of different error codes. So if I return 0 here at the end, you'll see that, well, the operating system will interpret it as a successful run. Now, in C++ 11, you should be allowed to do this. This should be a keyword. Now, this just means 0. Do you see how on my IntelliSense here down at the bottom, it evaluates to be 0? I would say, Chef, that 1 usually means failure. -1 might be a different exit code, for sure. If you want to look them up, I'll leave that to you. All right. So I am going to leave this just as 0 because it makes more sense to me. It's a successful run. And, of course, you guys have done this a million times before. This was hopefully the first program that everyone wrote. If I wanted to print something to the screen, of course I'll use cout. Print hello world. If I wanted to be a little more correct, let's do CS202. And let's go compile and run this code, just to remind you all. And then we're going to go full speed ahead here. So please reference the first YouTube video if you don't remember how to connect to Bobby. But I'm just going to kind of click on my saved session here. And I'll go ahead and log in here to Bobby. Now I'm going to go to my favorite folder. I always use a test folder. That test folder indicates that I don't ever want to save anything in there. It's just for test runs. I'll clear out my folder because I'm not interested in having anything in there that's old. And I will drag over this file. Just have to find it. I think I saved it as this. So I named this file CS135 review. .cpp. Now I'm not going to change directory. I'm sorry about that. but I am going to compile this. So this is going to be g++ dash std is equal to c++11, and then the name of the file. And what do you know? It compiled, and if I want to run it, I can do /a.out, and we get our print message, all right? So that was kind of for you, some of the few Java guys out there, or the Python people. This is how it runs, and this is the starting point of our program. So what we need to do in this program, so we need to read in a file. All right, we're going to read in a file. So I think that if we have a function for that, it will be nice to have. Now, I'll do it kind of the way that it is in the assignment. So you have this int here, which indicates the number of words that we're going to read in from this file. We're going to read in that file. Now, this is going to take some parameters. Now, the parameters I'm going to pass are two things. One, we need to store the data somewhere. Where do you guys think we should, what type could we store the data in? What kind of data structure do you think we should use if down here I want to say declare some variable equals read data, and we're going to call that function like that. Yeah, so I like the idea of an array or even a struct. I like both. A string type, yes. So that's, you guys are all 100% correct. So you have a few options here. We can do something like string words. And if I want it to be an array, I have to put some value in here. Now this might be considered a magic number. So what you should do is probably somewhere up here, you're going to want to declare a size for your array, right? So we'll use a constant size. Now, does anyone know, when I say this is a static array, do you know what I mean by saying static? Do you know what I mean when I say static? And can anyone take a guess? Const max. Unchanging. Okay, yeah. So you guys are all right on the money there. Static means not changing. It's static. It stays in place. So the most important thing to remember is that this array's size cannot change. And so because this array's size cannot change, I can either use a max number or a magic number, or I can declare, say, a constant integer, in which this can't change either. And so we'll be able to declare this static array, meaning when the program first starts running, it will go into the operating system and it will say, hey, give me an array of 100 words. Right? Yeah, constant memory. So it's static array. So we could read that in there. And we also probably want to use a file name, right? So Young asks, are global variables allowed in this course? For the most part, no. If it's a constant variable, then yes. But anything that's not like this should not be global. If you do have a question about being able to use something like that, you can always ask me and I'll give you a yes or no. In general, you can't use globals in this course. Unless, of course, you have a constant global variable. Constant. Okay. Now, we also want to read in, we want to open up this file, so we're going to need a few things for that, right? If we want to open up that file, we're going to need a few things. We're going to need to pull some things from this library. We're also going to need a file name. So let's work on that too. So this string words is going to hold all the words in our file. All right. And then we're also going to want a file name. So let's say we take a string file name. Now, actually, before I do that, there's a few kind of options here. This assignment uses Linux redirection. You guys did do that before, right? In which you can provide an argument to the executable. So I could say /a.out filename.txt, in which I will provide this file to the executable. Some of you did not have practice with that before, okay? So this is how assignment 1 works, all right? So pay very close attention to this part. Assignment 1 works by using Linux redirection. If I can spell, I'm a computer science major. And that means that the file name will be provided when the program starts. All right. Now, you probably love to use Google like I do, especially as a programmer. So we may even be able to Google Linux redirection if you're still a little bit confused. Perhaps we can find something in Geeks for Geeks, which is one of my favorite websites. And you'll see that you have some options here. Now I'm kind of just going to give it to you. Just give me 1 second here. In which int main will actually take some arguments. Now, if you've never used the redirection before, you've probably never seen that. And it looks kind of ugly, I'm sure. But int main will take some arguments. It'll take some parameters. The first thing it takes is int argc. Now, argc is the count of arguments. So I'm going to ask you a question here. I really can't spell today. In this example here on Bobby, arg, please don't make fun of me. In this example here on Bobby, how many arguments have I provided to the executable? It's not a trick question, I promise. I just want to make sure you understand. Yes, I've provided only one. I've only provided one. Well, I've only provided one. So let's actually see how it works. All right, let's see how it works. I've only provided one. In addition to that, we're going to have an array. Now, this probably looks a little bit scary. But this is the array of arguments, all right? argv is a character array. What's another word for a character array? What do we call those? What do we call a character array? It's a string, yeah. So it's just a string. Now this is, it's gonna be hard to follow. This is actually an array of character arrays. So this is, in other words, an array of character arrays. Now I know that sounds terrible. We're just going to call it an array of strings. All right, it's just an array of strings. And those are all the arguments. So let's go ahead and test this out. I'm not going to use this yet, and I'm not going to use this yet. But let's see what they are. So our argc, our arg count, will be what when we run it? Well, we're just going to go ahead and see it out. And we're not going to do the argv yet. So let's go ahead and take this on to Bobby. Oh, excuse me, there's my messy desktop. And let's run this code. Now, we would expect it to be 1. That's our guess, right? Because I've only provided one argument to this executable. But we may find that we're wrong. So in this case, I ran it, and I didn't provide any arguments. And it says, hey, this is number 1. Now, if I run it again, and I provide it with, say, an input file.txt, now it's 2. Let's say I provide it with another one. Now it has 3, right? So there's a.out, input file.text, and this file.text. So I kind of let it slip there, but and it might be hard to kind of understand, but the executable file is also considered an argument. So check this out. When we go ahead and come here into our C++, it's an array, so we can index this. We can index this array. So I can come to argv, and I can always type argv0. Mail asks, why do we not have to put those in parentheses in main? Could you specify what we would have to put in parentheses? Just to be clear. Line 19. These? Well, this is the parameter list. So remember, when we're declaring functions, every function has a type. Let's go ahead and open up some notes. I think it's probably best we got started on those. So I guess we'll start kind of here with some functions. Int main is a function, and every function has a return type. So we're going to say every function has a few things. The first thing it has is a return type. Second thing it has is a name. And the third thing it has are parameters. Or you might call them args, arguments. And so every function follows this form. Return type, function name, parameter list. Separated by commas. And then it has some body, in which there's some code within this function. So we don't remember what parameters are. Yeah. So parameters are variables. You could call them, they might not actually be considered variables. We'll just call them, in this case, vars. Arguments, parameters. That they're just variables that are provided to the function. Now, Chef, you're asking about function overloading. That will come next week. We do have that as a subject. I don't think you covered that in CS 135, so I will not cover it yet. Next week we will, though. So I guess we'll do some examples here. But these are just variables that are provided to the function body. And when I say body, I'm talking about the brackets. Anything inside the brackets. Right? So the body would be the code inside the brackets. So any parameter that's provided to a function is just some variable that we have access to within that function. So let's actually stop this for just one moment, and let's get started on our read file. So what our read file should take is probably this string words array that we made. Here it is, string words, because we're going to want to save all of the words into this array. So the first thing we're going to want to give this function access to is the words array. And the next thing that we want to give this function access to is probably the file name. We just want this function to know what the file name is. So we're going to just do a few test runs with this. I'm not going to code this function yet, but I am going to just put some example code in here. We're going to do some cout statements. So down here, I always like to put my function definitions below main. All right. Now the function prototypes go above main. Do you guys know that? You guys know those terms that I'm talking about? Prototype. Someone might call them headers. So up here, I'm just specifying that this function is a thing. It's alive. It's accessible. But the definition will actually go down below main. All right, so I'm happy that you guys know about that. So here we have our code. So all I'm going to do is, a way to think about it, this function has access to two variables. In this case, these are not constant variables. The first one is the words array. It also has access to this file name. So in fact, if I just put cout fname, whenever I call this function, and however I provide, whatever I provide as a parameter, it'll get printed out here. Now, this is an integer function, so it has to return an integer. So down here for now, I'm just going to do a return 0, but we'll change it later. So up here in main, if I say, let's see here. I have this code already typed. Read data. Now, how am I going to call this function? Can anyone tell me what a function call to this would look like? Assuming that I have the words array and I also have my file name here, which is probably going to be equal to, say, inputfile.txt. What does a call to that function look like? What do I have to do here? Right, I have to pass in those variables. Now the order matters. So the words variable will come first. Right, so notice that the types will line up. This is a string array. So I need to pass a string array into it. So the first thing that comes in is the words. Now the next thing, it's looking for a file name. Now, Cade, you're right. There's two ways to do this. I could either do it this way, because this is a string, and so it would actually work this way. So let's go ahead and just run that code, and we actually will see. We will actually see that this gets printed out. Now, Chef asks, do I need the brackets here? The answer is no. And I'll tell you why. Notice here that this is taking in the whole array. We are providing the entire array to this function. We are not providing just a string. If we were to provide just a string, I would come in here and I would index that array at some location. But we're actually providing the whole array. And so we're actually not, and this actually doesn't mean anything to us. If we put brackets here, it thinks that we're going to index this array at some location, but we're actually not providing some number to it. So it actually doesn't know what this means. I would assume that the code would not compile this way. If it does, I'll be very sad, but I'll just hopefully prove to you real quick that the compiler will not be happy with that. So look, we got this big error here, and it's talking about this thing. All right, it's talking about this. It says, what is this? I expected an expression to go inside of these brackets. I expected a function to go inside of these brackets. And so no, the answer is we will not put the brackets there. And you guys did answer Pig's question there. This is just going to keep track of the numbers in this file. All right. So now if I save this, I fix my compiler errors, and I pull it back in here. We're going to see that this function that we've called, it has access. I probably did it wrong. Give me 1 second here. I may not have loaded it. I may not have saved it. What is my problem? Just give me 1 moment here. Now, I'll do this plenty of times in front of you guys. I've been coding C++ for many years, though I am still not perfect. So let's figure out what my problem is. Now, these errors are just a little too big for me to see, so I am going to make it just a little bit smaller. But I'll tell you what I see. So under here, it's saying that string was not declared in this scope. Now, I wonder why that is. And I'll tell you why. Are you guys ready? So look what it says here. It's kind of telling us, this is kind of a hard one to figure out. Look what it says here. It says, was not declared in the scope. Did you mean std string? Now this was a goofy mistake on my part. Notice that I've used a namespace underneath the read file. That was a very goofy mistake by me. So in fact, I should bring it up here, right underneath the libraries. And we fixed most of them. Now we do have one more issue. And it's likely that I misspelled this somehow. So let's go ahead and take a look at that function. Did this std thing make sense? It needs to be above this function. Unless I'll have to do this with every single string I type. You're right. You are 100% correct. Read file. All right, so that will fix our compiler errors. It's always good to stop and compile our code as we go. As you can see, I too get ahead of myself all the time. So that did compile. So now we can do a nice a.out, and you'll see that this input file.txt, where did that print? Well, here's where main starts. The first thing we did was declare an array. The next thing we did was declare a file name. And then we called this function here. We said, hey, this variable will be equal to this function. We passed in input file.txt, and down here, that's what this became. So fname contains input file.txt, and so it printed it here. So I guess back to the original question, do these have to be in parentheses? Well, they are. These are the parameters of main, and these are the parameters of read file. Whatever we put in for them, in this case input file.txt, that is what this file name will be when we call this function. Does that make sense? Do I need to spend more time on what a parameter is? If I could, well, I'm curious a little bit as to what our question is, or what the confusion is. Uchu says it'll see out input file.txt. That's correct. You are right. Let's give it another run here. So instead of passing this in, let's say I passed in something like CS202 smiley face. So we've declared this file name here. Now, this could be anything. I could just call this F if I wanted to. Now, whenever I call read file, I need to provide stuff to it. Otherwise, it won't work. So if you learned about functions in 135, you should have learned about regular parameters for regular functions. You're asking about the main parameters. Is that what I'm hearing? It's not about this. It's about the parameters in main. Is that correct? Okay. Yeah. So that's kind of what I'm okay. Thank you. You're right. So I want you to think about it this way. Now, this is Linux, all right? So Linux does not equal C++. Hopefully we know that. Linux does not equal C++. So in Linux, we're not going to call functions like we do in C++. And so the way that the Linux line works is we're going to see something like, let's take notes. This is what I need to focus on here. Where are we? So in Linux, we have something called a command line argument. A command line argument is just like a parameter in C++. All right, just like a function parameter. And so this is kind of how it works, all right? This is just kind of how it works. So if we say something like ./a.out, and then we say input file .txt, now this is Linux. Similarly, in C++, it might look like this. It might look like, say, run. What file should we run? Well, we're running ./a.out, and we're going to provide it with this input file .txt. Now, this might make you happier if I call this main. It says, here's what code should I run. Well, I'm probably confusing you. This here kind of converts to this. But even more so because of the arguments, here's more what it looks like. It will look like main. How many arguments were provided? Well, there's just 2. And what did they come in? Well, they come in this array. The first thing is ./a.out. The second thing is input file .txt. Now, if you would prefer, I'll put them in double quotes to indicate what happens here. So what I'm saying is there's really no way you can think about this in C++ terms other than that when you call ./a.out input file, it kind of becomes this. Synthos, to answer your question, which you asked, do the main parameters get the program name to run it? That's exactly correct. In the sense the operating system will execute some program, and it says, what, have you ever, well, probably not. But there's things like PowerShell, or even if you go to your command line, I'm sure if you've made Minecraft servers before or something like that, you can type in CMD for command prompt, and you can manually run programs. I could say something like exec Minecraft.exe. And so exec says, I'm going to run a program, and then it says, what program am I running? So to answer your question, yes. When we say ./a.out, what Linux does is it calls its exec function, and it says, what is the object file? What is the executable? And the answer is this one. It's a.out. So please, well, let's even just check this out real quick. So I'll show you. So this will be the number of arguments, and this will be our array of arguments. And so down here, we're going to print out the number of arguments, and then we'll print the very first thing here. And I actually might be able to help it make sense. Is it kind of coming along, though? Do you guys sort of understand what happens with a command line argument? We're like calling this exec function, and we're saying, hey, I'm going to provide some things for you. First thing here is the program. So check this out, then. If this is the number of arguments, I'll tell you why we need it in just a moment. I'll show you. Okay, I'm glad we're getting there. So I'm going to show you something now. So let's do a for loop. Let's say I want to print out everything that we provided as an argument for the exec command. Okay, let's print out everything that we'll need. So here's how we do a for loop. Hopefully you remember those. What does this for loop do? This says for all, for I equals 0 until I is equal to argc minus 1. So if we provide only one command line argument, I will be equal to 0, and then the for loop will exit. If we provide 2 command line arguments, then it will be equal to 0, then it will be equal to 1, and then it will exit. So here's what we can do. We can say cout argv indexed at I is equal to argv located at I. And I might even put a little thing there. Let's print out every single command line argument that we get. Let's print out every single command line argument that we get. So here we call just ./a.out. So only one command line argument was provided. It was the executable file, and it's stored at index 0. Now if I run it again, but this time I put input file.txt, notice argc here is now 2. A.out is stored in the first index here, and input file.txt is in the next one. So the more arguments I append onto it, we'll have access to it in main. So tell me, what does this do for us? Do you guys have an idea? What does this do for us? What if I put input file.txt here? What can we do with it? Do we have to then ask the user for a file name? We say, hey, please input your file name. Instead, you're only going to run this program with the file name. So check this out. And stop me if I need to. I'm going to actually save this for now so you guys have access to it, and I'm going to make a new file. Right. Well, Durgan says you don't need to use the in file. You do need to use an if stream, but you don't need to ask the user for the file name. So I'm actually going to make a new text document here, a new CPP file, just because I want this one to be Linux redirection. So you guys can use this program if you need. All right, but for now we're going to move on to this one here. All right. Yeah, exactly. So check this out. Are you ready? We're going to have some fun here. First, let's see if a file name was provided. How do we know if a file name was provided? Can you tell me? How do we know if a file name was provided? How do I tell the difference between ./a.out and ./a.out input file? How do I know? And I'll answer this question here. Normally, if you throw things after the ./a.out, it just ignores it. What the argc and argv does is it will save the arguments. Yeah, is what it would do. So you guys are kind of on top of it. Argv, Chef nails it, and Pig nails it. argc will be equal to 2. Look at this. What is argc equal to? Argc here is equal to 2. And the input file will be stored in this value, right? So that's exactly the check that I'll do. So I'll say, hey, if argc is greater than 1, this means a file name is provided. I already have that comment there. We can do our code. Else, let's do a command here that says, hey, cout, this program needs a file name provided. And then you might say something like usability. How do you use this program? Usability. And we'll say you better type ./a.out file name. Here. Okay? But if argc is greater than 1, then we know that we have a file, so we can go ahead and do our code here. All right, you guys with me so far? Mail asks, argc counts how many arguments there are. And argv says what the argument is. Yes. We need to do this check, because if we just were up here all willy-nilly and we said, hey, argv at 3, what if there is no fourth argument? We're going to cause our program to break. Do you understand that we need to check the argc before we start going into that array looking for things? I have expected you to learn, probably in CS 135, that you always should keep track of how many elements are in your array, or how big the array is, so you don't go out of bounds. So I hope that you understand that, and so we're going to have to check for this argc first. So let's do a fun little cout statement here. And string f, well, guess what? String f will actually be equal to argv located at 1. This is our file name. Does that make sense? I'll call this the file name. So we'll store all of our words into this array, and we'll store the file name inside of this string. Thank you for saying yes. It helps me. So now we're ready to read our data. All right, so we're going to move on to this function here. All right. Yes, yes. Jovany, you're right. We'll need to check if the file can be opened, and we'll store it in the array. All right. I'm glad it makes more sense now. I'm glad it makes more sense. So let's go down to this read file function, okay? Let's go down to this read file function. So the first thing we need to do is make a file. Now, I know someone already typed it, so I'll give this one to you. But I will ask you a few other questions. All right. Now the I stream, for those of you who don't know, F stream indicates a file stream. F stream indicates an in file stream. So what does OF stream mean? What does OF stream mean? Output, right? Yeah, it's going out. It's kind of a write file stream, right? Now, there was a question up here. Let's see. argv1 is just the second character of file name. So, Cade, this is a little hard for us to wrap our minds around. This star here, this is a pointer. Now, we're not covering pointers yet, so I'm kind of waving my magic hands here. And I'm kind of asking you to believe me. But argv is an array of character arrays. It's an array of arrays. More so, it's an array of strings. And so argv actually returns something like this. I'm just going to call it maybe an I file. You get it, right? So this is what argv comes in as, is this character array, which is a string, right? So I'm glad that kind of makes sense. Now, if I did 1, 1, that will give me the F, right? That'll give me the F. So we're going to need this in file here, right? This is an if stream because we're going to be reading in. And if I want to open this file, do you guys remember what that looks like? Well, if I want to open this, what do you think I do? What do you think I do? You guys remember? In file open. That's right. That's right. So let's go ahead and try to open that. Looks like this. And we're going to pass in the file name, right? Now, if I wanted to check to see if the file was open, how do I do that? All right, Durgan, you're so right. All of you are on top of it. Thank you. Oh, and Mail is already ahead of me. You are already ahead of me. It'll look something like this. If infile dot is open. Yep, Cade, you're even more correct there, right? Yep. Else we'll say cout file open failed. And we can return 0 here. Here's what I'm going to do is I'm actually going to declare an int word count here to be 0. And down here, I'll just return that word count. So if this if statement happens to be false, and we do not execute anything that's in this body, word count will not be modified. It will not be modified, and we'll end up returning 0 anyway. All right? So that kind of works out for us there nicely. But if the file is open, we can begin reading from it, all right? We can begin reading from it. Now notice in here, we've got all this stuff here. We've got all this stuff. So we can actually just read in each string as we go. So check this out. If I wanted to store something from that in file into a stream, into a string, let's say the red word, how can I read something into it from the in file? Just a single word. Let's do read a word, just one word. Yeah, we will use a while loop or a for loop. That's good. That's good. That's good. You're way ahead of me. And we will use the, so I'm going to call that the extraction operator. Yep, Synthos, you are way ahead of me. I'm so proud of you guys. All right, so, yeah, so there's two options, actually. I'll give you two options here. This one is my favorite. All right, this one is my favorite. But if you don't like that one, you can do this. While the in file is not at the end of file. So this says while, this while loop says while there is data, while are not at the end of the file. All right. So that's fine. I think we'll prefer it that way for now. But you could actually, if you really want to, you could just throw this inside of the while loop. All right, I'll leave that one up to you. So we'll read in our word. And just for now, let's stop and test our program. So someone asked me last class some tips to pass this class. Well, I have quite a few. One of them will be to, stop for a while, take a breath, and see if we're actually reading anything. Let's see if this code compiles before it gets too out of hand. You know what I mean? So let's do some tests. Let's see here. So I think I saved it as this one. So I named this file WP for some reason. And everything compiled. So far it works. Now, guess what? If I just call /a.out, look at this. Look at this. This program needs a file name. So the program exited successfully. Nice and graceful. We didn't get a seg fault or anything like that. And basically, what it told us was, hey, argc is not greater than 1, so you are not allowed to use this program. Now, let's go ahead and test our next thing here. Let's provide our file, but let's provide the wrong file. Let's provide the wrong file. File provided. Yes, a file was provided, right? Synthos, to answer your question for assignment 1, we need to use that Linux redirection. Unfortunately, well, I won't say unfortunately, but yes, you do. And that's because of the code grade. So, as I'm sure you know, code grade works by matching outputs or inputs, kind of both. So, if you try to do the file name like entry, if you say, can you please enter the file name, code grade will say, hey, I wasn't supposed to run that way. And like I said, I spent some time on this last class. I am not a fan of CodeGrade either, but I am required to use it. So I'm here for you to help you use it. So use me as a resource to help you use it. Instead of getting mad at the CodeGrade, allow me to help you. All right. And the first thing you're going to need to do in assignment 1 is to use this redirection. All right. So obviously we provided the file, right? Let's see. We provided the file. Yet the file name was not correct. The file open failed. So now let's provide our real file. / not the wrong file, but the input file. Now, I don't think it'll run, and that's because I didn't upload my input file. So I'll take the time to do that real quick, and let's give it another shot. Oh, what do you know, folks? It looks like we're getting every single word, one by one. Let's go ahead and test that. Let's go ahead and look at it. Come here. Okay. 28555 1256 645. Looks like things are good. So, are we okay? Are we okay? And yeah, Pig, I agree with you. CodeGrade has, there's kind of two parts to it. One is I feel like I almost need a degree myself to operate it. And two, it could be made more, it could be made better, I feel like. But it's hard to do. Yeah, so Uchu, you said you use getLine. Getlines are good for specific purposes. All right. In terms of this assignment, you only need one word at a time. So you only need to read one word. If you were reading in, say, like an Excel sheet, you're gonna probably want to use getLine instead. Klaus asks, would you recommend us making a smaller text file to test your code? Absolutely. That's a great idea. You should definitely do that. Chef, we will go over structs. As you can see, we're taking some time to do it all. So we'll get to the struct next. All right. And if we don't get to it, I may extend the assignment just a little bit. All right. So we'll see how far we get today. We're just kind of doing our best right now. And Durgan, you're right. getLine is good for splitting up information from Excel. That's correct. So that's our read file. All right. So let's go ahead and just store each of these words into the file or into that array. So we're going to start at 0. So I can say words located at the word count is equal to whatever word that we read in. And then I can do this. Now, I prefer to do it this way. You guys might think this is simpler. That's fine. You can do ++ word count. You can do ++ word count or word count ++. You can do word count is equal to word count +1. Now, my favorite one is this because it makes the most sense to me. I like to do the += one. All right. You guys may not have seen that before. This just means this. All right. So that's me incrementing the number of words. I will give you a sorting algorithm, Chef. I will give you one. And Giovanni, you're correct. We're just going to save those into the array. All right. So once we read this file, we should probably close it. Now, the reason we close our files is, have you ever tried to open something in some program and it says, I can't open this because another file has control of it? This is why we do this. All right, so if your program runs for 10 minutes and then you try to open it during the runtime, it will say, I can't open this file because someone else has it. So this is why we close our files. I'm a little confused on Linux redirection. Is that where you just move the CPP file from the VS Code to your Linux? No, Waffle, that is not correct. That's like SSHing. That's kind of just uploading your files. Linux redirection is this. Linux redirection is when you provide things to the file. So Linux redirection means this. That I have provided something to the executable. You can actually do a whole bunch of stuff with it. You can like put an arrow here and say, I want all of my output to go to this inm.txt file. There's a whole bunch of stuff you can do with it. In the case of this class, it's just when you provide a file to the executable. A string, I guess. So hopefully that makes sense. And whenever you do Linux redirection, int main will have some arguments. It'll have some parameters. All right, so you guys are happy with this read file function. If we want to check it, let's go ahead and check our words. Int I is equal to 0. I is less than the number of words that were read. I++. Let's go through this array one by one, and let's say, hey, cout words located at I. All right, and let's see how we did. All right, looks like it worked. Looks like we got all of them into that. Array. All right. So now I'm going to try to take our last 10 minutes to talk about a struct. All right. I'm going to take the last 10 minutes here to kind of talk about what structs are. Now let's see so far what we've talked about. I have not been taking very many notes. Everything we went over today, I will go over in the notes. So I'll be sure to put a little bit here in the file, opening files and whatnot. In addition to that, let's just kind of start some struct notes. Structs are something very interesting. These are custom data types in which the data type contains multiple data, however you want to call it. Multiple datas. We're going to use kindergarten language here. All right. It's a custom data type. Now, many people refer to this as an object. This semester, next week, we're going to start learning about objects. All right. Structs might be considered an object. So what does a bird have? We're going to make a struct for a bird. Our bird might have, well, I don't know, maybe a weight. Our bird probably also has some eyes. Let's do maybe height, maybe a wingspan. Maybe it also has a string species. Maybe it also has a bool, can it fly? Right? Yeah, Giovanni, you're right. So one bird has all of these things. And basically, we're just kind of combining them all into one type. We're combining them all into one type. Yeah, chickens can't fly, right? Maybe they can for just a short amount of time, but I think that's fair. So that's kind of what a struct is. It just contains multiple data. And so in your assignment, you're expected to have a few structs, maybe just one. No, you have two. One struct is a unigram. And the other struct is a bigram. Now, I'm doing something very similar to the assignment in this example, so I will kind of delete these, but it'll be pretty much the same. And in a unigram, it says, hey, I want to keep track of what this string is. What's the string? I also want to keep track of how many times it's in the text. He calls this frequency. So when I'm down here in main, if I say something like unigram, mygram. How do I access? Now, Cade, you say this is a global struct. The definition for this struct is global. I wouldn't say, yeah. The definition for the struct is global. If I were to do this, const unigram mygram, this is now a variable. This is now a global variable that has the same type as this struct. So you guys hopefully understand that this is a custom data type. It's just like an int, a bool, a string. A string in some sense. A string, actually, in some sense, is a struct. And inside of that struct, you have these things. You say, hey, I've got a character array. I also have an int string length. All right, a struct. A string, in some sense, is a struct. It's actually a class, but we're not going to get into that yet. All right, but in some sense, a string is a struct. So in the assignment, you have structs, unigram. If I want to access something in that unigram, how do I do it? Do you guys remember? Let's say I want to put something like I want to put this string mygram in there, and I want to say it's inside the text 4 times. How do I do it? You can type code, stuff like So Synthos, you're right on the money there, right? In a string, you can use dot size, unigram dot frequency, right? We use the dot operator. So let's see here. Object. How do we get variable? How do we access the data inside? Well, we use the dot operator. So what I'm going to use is obj for object dot my var or something. Okay. Use the dot operator. So what does that look like? Well, we're going to say, hey, mygram dot frequency is equal to 4, and I'll say, hey, mygram dot string is equal to my gram. Okay. So I only have 5 minutes left. I'll go as far as I can, but I just want to check with whoever it was who talked about structs just a little bit ago. Are you kind of following? Do you think that you have enough information to kind of dink around with on the assignment? I am going to, of course, do some examples with that. Yes, you're correct. I'll put a semicolon there. All right, chef. Yeah, I'm happy. So I'm not going to give you this. So with a bigram, you probably have string 1, you probably have string 2, and you probably have the id frequency. All right, so that's the bigram. Yeah, and you're totally welcome. We're going to finish it up next time too, because well. So I'll check the schedule, guys, to see what our timeline is. We are luckily a Tuesday-Thursday class. The Monday-Wednesday classes get screwed. I've been there before. And we have on the Monday-Wednesday class, there's a few days that get taken off. So we might have the time to do it. If we don't, I'll actually wrap this review up on a YouTube video. But this weekend I'll see, or rather tomorrow, I'll see if I can spend some more time on it. So just look out for announcements. But for now, tentatively, I will continue with this on next Tuesday. Now, what I'm going to call this is just a number. And instead of a string, it's going to be the num and the number of times that it's in the text, right? So I want to know how many 8s are in this text. I want to know how many 9s are in this text. So it's kind of the same thing from the assignment. So we've got a number. Now I'm also going to make another struct just for fun. I'm going to call this the number dictionary. All right, the number dictionary. And similarly, in the assignment, you keep track of unigram arrays and bigram arrays. Unigram and bigram arrays. So in this case, I'm going to keep track of number arrays. And in a sense, it's going to look something like this. 1 is in the document 7 times. 3 is in the document 54 times, something like that. So this number dictionary, I'm just going to say, hey, we've got a number, num array, and I'm going to declare this to be maybe the max array size, and I want to keep track of array size, or how many elements are in that number array. All right, so we'll use 2 structs. Yeah, so Jovany, that's kind of what I need to spend some time on. We're going to go through this text. We're going to convert every character to a lowercase letter. We're going to remove anything that's a non-alphanumeric character. And then we're also going to convert, say, 7 into digit 7. So there's quite a few functions we'll use. And as I said, we won't get to them today, but that's going to be our goal. All right, there's plenty of stuff on the internet that you can reference. So, with the 2 minutes left, I'll just tell you kind of the functions that I'd like to go over next time or in a video review. All right. And where did I put those? Okay. So we have a read file. I'm probably going to do a string clean word, which takes a string s, and what this will do is it cleans the word. I'll probably have a convert to int function. So this will be int convert word, which takes a string s. I'll probably have a clean whole array. Save to a log maybe. All right, so that'll probably be a void clean array. And the way that I'll do that, like I said, I'll have to get to it later, but we're going to take a number dictionary and the words array. All right. And then, of course, we'll have a sort. All right. The sort will also be a void. And it will actually take this number dictionary. Both of these need to be passed by reference. I will get to that in the rest of the review when I have the chance. All right. So I'm going to stop it there for today. I hope this was helpful to you guys. Once again, I'm just going to double check on our time constraints. And I might throw the rest of this review in a quick YouTube video for you guys that you can watch. All right. Of course, we had to learn about Linux redirection today, so maybe not a huge problem. Hopefully you guys understand that. I'll upload this Linux redirection example for those of you who would like to play with it. You should have enough work to at least get started with some of these things. All right, go ahead and get started. I'll reevaluate if I need to. And that's what I got for you today. So thanks for coming. You're free to go. Mail, you're so welcome. Cade, you're welcome. Uchu, you're totally welcome. Pig, go ahead and hang out here for just a second. I think I'll be able to post a link for you right now. Let me grab that. Here you go. Top Wolf, you're welcome. YCS, you're welcome. Waffle, I'll see you later. Yang, you are welcome. Fuzzy, you're totally welcome. Make sure to hydrate for sure. I keep spilling sake. That's what I'll call you unless you don't want me to. You're welcome. Klaus, you're welcome. Synthos, you're welcome. Jovany, you're welcome. Oyman, have a great day. Damon, you're welcome. Hamma, you're totally welcome. Chef, I'll see you later. Durgan, you're welcome. Chef, the file will go on Canvas right now, and the video will go up on YouTube right now. Pig, you're welcome. And I'm not sure what arguments means, but yes, both of those will go up. I'll also be in office hours if you want to come by. Oh, yeah. Okay. Sorry about that. You're right. I wonder if I changed it. I think I got it. Oh. Yeah, it is. All right. Come to office hours if you need. I'll see you guys later.